is the video for 2.6C, in which we are going to discuss skewness and standard deviation. So first off, we will talk about skewness. And so, I don't know if you guys can see my head. I tried to move it on my screen. Maybe you already saw it. Anyways, skewness is just talking about like if it's lopsided or not. And so it says data is said to be skewed if there's a large concentration of small values with several other larger values. So in other words, it's a frequency table, and some of the towers are not a frequency table, a histogram, and some of the towers are short and some of the towers are big, and it gets skewed. And so you can tell if it's skewed based off of where the mean is located. So this is the formula they use. So I like to think of it in terms of where on the number line. Let me just draw a couple of pictures so you can see what I'm talking about. If I had a histogram like this, and it got smaller and smaller and smaller, then on here, the median would still be in the middle, but the mean would be dragged down with those smaller values. So the mean is actually smaller than the median. In the opposite scenario, if we have these tall towers and then they get smaller and smaller and smaller, then again, the median is right in the middle, but the mean on this one is actually going to be a little bigger because those larger values, when they get averaged in, they make the mean bigger. So when the mean is on the left, we say that this one is skewed left. And when the mean is on the right, we say this one is skewed right. So really, you just need a number line. You need to know where the mean is. And once you know where the mean is, then you're able to tell if it is skewed left or right. So looking at the first three examples, at the beginning, it says the mean is 78 and the median is 69. I'm going to write those in number order. 69 comes first, and then 78. 70 is the mean. 69 is the median. The mean is on the right, so this is skewed right. You're just looking for where the mean is on the number line. Okay, this next one, we have a 44 and a 46. 44 is smaller, so it's on the left. It says 44 is the mean, and it says 46 is the median. And since the mean is on the left, then this one is skewed left. Now there's one other scenario I forgot to mention. It's the last one listed here, and it says it's symmetrical if the mean equals the median. So in other words, that picture would look like, oops, it would just be like this super boring histogram. Everything's equal across the top. Kind of looks like a sentence. Anyways, so we have this. Don't know what happened there. We have this last question. We can see that they're both 110. So this is symmetrical. Another word you might see is uniform. Either word is fine. Okay. That's it for skew. Skew isn't very exciting. What I want to talk about is variance and standard deviation. And so standard deviation is the measure of dispersion of data from the mean. In other words, we have the mean in the middle. How far out is the data? And the farther out it is, the bigger the standard deviation. And similar to standard deviation is variance. Before we get to variance, there are two symbols that we're going to use for standard deviation. And actually, I just want to kind of make this little table that has all the symbols on it. So we've talked about mean, and we're going to talk about standard deviation here. And we have the sample, and we have the population. So the sample mean we've discussed is X bar. The sample standard deviation, the population mean we've discussed is mu. For standard deviation, the sample is S because samples always alphanumeric letters. So X bar and S, those are both letters from the alphabet. Whereas population standard deviation is going to be Greek letter. So this is a lowercase sigma. And you can see the sigma typed out down here. You can see we have the sigma and the S. So this one is for the population, and this one is for the sample. Okay, we'll get to that formula in a minute. But some things, so variance is standard deviation squared. So another way to say that variance is either S squared or it's sigma squared. It has two different ways to write variance because it just depends on if it's the population or the sample. But either way, it doesn't have its own variable. It's just standard deviation. Okay, a few key points. Standard deviation is always positive. Standard deviation can be 0 if all the data values are equal. And a standard deviation gets larger as the data is spread out. So if everything is the same as the mean, every value is equal, we have 0 standard deviation. As the data values get farther away from the mean, the standard deviation, or the space between my fingers, getting bigger and bigger and bigger, but it's always positive. I can't have like negative space. I don't even know how to show you that with my hand. So it's going to be positive, or some rare occasions it could be 0, but it's never negative. And then the last two, standard deviation has the units of the original data and can be influenced by outliers. Okay, how to compute the standard deviation. So from, first we want to find the deviation from the data of each data from the mean. In other words, deviation is like the difference, things that are different. People that have deviant behavior are different than the average person. So if these are going to deviate from the mean, they're going to differ, which in math terms means subtraction. So we subtract our data value minus the mean. Step 2, we square each data value or each deviation. Step 3, we add the squared deviations. And step 4, we are either going to divide by n. That's not my highlighter. Hold on, let me get rid of that. We're either going to divide by n if we're talking about the population, or we're going to divide by n minus 1 if we're talking about the sample. So n for the population, n minus 1 for the sample. And since these are not the same, they're different formulas, that means sigma and S are going to be different values every time. So you need to know if you're talking about sigma or S, population or sample. Okay, everything up to here that we've done so far and above, this is all the variance. So then the last step, to get the standard deviation, we are going to take the square root. Okay, it's a lot of steps. It's a messy, ugly formula. So what we're going to do is just kind of go through it step by step, and then we will do a shortcut because it's terrible. Okay, so first thing we want to do. So for this data, I'm just going to tell you that the mean is 21.3. We'll confirm that later, but you know how to find the mean from another video, so I just wanted to focus on the standard deviation. So in order to do this, we're going to write down the numbers, and it doesn't matter the order. It's not the same as median, but since there's only 6, I like to put them in number order just to kind of see patterns if there are any. And so the first thing we're going to do is we're going to find the deviation, or in other words, we're going to subtract the mean. So here's our mean, 21.3. So we have 15 minus 21.3, 17 minus 21.3, 19. Do you see the pattern here? Every number in the X column minus 21.3. And now that we have gotten to 22, now we have a bigger number in front. And so we're going to start getting some positive values, but keep subtracting 21.3. So on the calculator, I'm going to go up to calculation. Oops, I was doing lots of fun stuff. Oh, I think that was from the last video, actually. Okay, so I'm going to do 15 minus 21.3, and I get negative 6.3. And I'm just going to kind of do this all at once so I don't have to keep typing so much, but this negative 6.3 is going to get squared. And when you square a negative, it's a positive answer. So what I'm going to do, instead of having to worry about the negative and, well, I don't know how this will work. Let me see. What happens if I hit? Okay. If I hit answer squared, it should give me a positive value, and it does, 39.69. So do you see how it said answer, but do you see now how it's like in parentheses? So you could type that in parentheses yourself, or you could just hit that answer button. And I need to just pause this for a second. Oops, I can find my mouse, and I will be right back. Okay, sorry about that. I had a quick phone call, and with kids in sports, you just never know how urgent it is. But I'm going to finish this video before I go to town to figure it out. So let me just get back to sharing. And okay, so where we left off was we have 17 minus 21.3, which is negative 4.3. I'm going to do my little trick again just to show you what I did. So it's a negative. So if I hit answer and then I square the answer, it's going to square the whole negative, the whole 4.3 and everything. And I get a positive 1849. I'm not going to write out everything squared anymore because I got to, we're ultimately after that final answer. Okay, so if I have 19 minus 20, oops, oh gosh, made it mad. Okay, 19 minus 21.3, and then I square that answer. I don't know what I did. Okay, hang on a second. Let me just back up. Okay. Oh, gosh. 5.29. There we go. That was negative 2.3. Okay, while I was doing that, I actually just discovered another trick. So watch this. 22 minus 21.2. 3. I was doing so good with no mistakes, and now I'm just keep messing up. Okay, 21.3. Now, I was hitting answer squared, but actually, if I just hit squared, it gives me it already. I love shortcuts. So this is 0.7, and the square is 0.49. 25 minus 21.3, enter, square, enter. Gotta love it. 1369. Okay, but when I say gotta love it, I meant like gotta love my little shortcut, but you gotta hate this process, right? Like it's kind of a pain in the butt. 8.7 squared. Where's my square? Squared. Why is it getting mad at me? Okay, whatever. Answer squared. I don't know why it didn't work that time. I hit something wrong. 75.69. Okay, now I want to add the square deviations. We're like halfway done with this problem. Plus 1849. I don't know, something's going on. I'm just going to use my keyboard because it's getting mad at me. 529.49, 1369, and then 75.69, 153.34. Okay. We just got to step 3, add the square deviation. We still have 2 more steps. So the next step is to this. Okay, so this right here, this X bar, this tells me that we are dealing with the sample. And so since we're dealing with the sample, we're going to solve for S. But we're not quite there yet. So S squared is going to be 153.34 divided by n minus 1, 6 minus 1. I'll come over here, get that number divided by 6 minus 1, which is 5, and I get 30 0.668. Last step, finally, is going to be S. This is the square root of the step above. So I'm going to do square root is next to the square button, and then of the answer, and I get approximately 5.54. That's terrible. Like, clearly there's a better way, right? Like, we don't want to do this forever. I'm glad you asked, because of course there's a better way, which is this lovely calculator. So go home, go to statistics. So everything in this chapter, we're either calculating it or we're going to statistics. And I want to go to my list. I'm going to clear whatever mess I had in there from before. And I'm just going to type in my list. So I have 22, 30, 25, 19, 17, and 15. Easy peasy. I just have to type in those 6 numbers and I'm done. Numbers, remember, are over on stat, so I hit OK. And then I go down and there are 2 different places. Right here, standard deviation, and right here, standard deviation. Remember, we're looking for S. So this one is sigma. That's not what I'm looking for. I'm looking for the sample standard deviation, which is S. And there is the exact answer that we just calculated, 5.537, blah, 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 5.54. So, oh my gosh, what was that? 15 seconds compared to like 10 minutes? Yes, obviously we want to do it with the calculator way. So let's look at the next example. I'm going to go back to my list and clear it. Confirm. Okay, number 5, it says Sam has 20 rose bushes. The number of flowers on each rose bush is given here. Compute the standard deviation. So we have to type in the list and we have to figure out, are we looking for S or sigma? Okay, I'm going to type in the list first and then worry about S or sigma. So I'm going to move the keyboard. I don't know why I keep putting it over there. But here we go. We have 9. I really hope you are doing this along with me at home. And if I am going too fast, then please pause. Because I know, like, I'm typing on my computer, which is way faster than when I type on my phone. So if I'm going fast, if you're using your phone and you're following along, then just pause it or just wait for me to start rambling or something like that. Okay, so I got everything in. Go to stats. Now, population or sample. I know that Sam has 20 rose bushes. So the population is 20. How many did we get data from? Well, I know from here, this problem right here says n equals 20. Oh, I can't write on that. N equals 20. So population standard deviation. So the final answer, why is it getting mad at me? Oh, the keyboard is in my way. That's it. Sigma equals this number right here, 2.98. And that's it. So I knew it was population because they told me there were 20 and then they gave me 20 data points. If they were told me there was 20 and they only gave me 10 data points, then it's sample. If they only gave me 5 data points, then it's sample. But they gave me all 20 data points, so it's population. Okay, last but not least, going back, can't scroll it out any farther, we must be at the end. I'm going back to not the beginning, but towards the beginning of standard deviation, we were talking about variance. So this problem is giving us the standard deviation, and it says to compute the variance. So all we have to do is remember that relationship, that variance is standard deviation squared. Therefore, in order to find the variance, we are going to take our standard deviation and square it. It doesn't matter sample or population, it's just to square the number they give you. So we don't know, we'll just call it S squared. It doesn't matter because we're not choosing anything, we're just taking the number that they gave us. Oh, I did want to point out, they do have variance on here also. But that's not what we're looking for, we're just computing. So I'm going to go home, calculate. 7.54 squared. And then here it doesn't say what to round to, but it's talking about money. So it's going to be 56.85 to go to the nearest cent when it's giving us money. And I lose my mouse when I switch screens. So that is all that I have for chapter 2. And so unit 1 is done. Get your homework in, get your quiz in. Email me if you have any questions and if you're ready for the test. Cool. All right. See you in the next video. Bye.